Hi there, everyone. So this is just a little bit of a supplemental video to help with the atomic structure worksheet and atomic structure tables in general. And I know that this can be a bit confusing at first because a lot of those terms are similar. Sometimes numbers are the same, sometimes you add, sometimes you subtract. And so I want to give you a few more examples since I was only able to get through a couple in class. And first things first, especially if you missed class, but even if you were in class, it might help to go through the notes one more time because terms like atomic number and mass number and protons, neutrons, electrons, all of that is there and important, and it's going to help understand this table a little bit better. So I would check that out first. And then once you're able to approach one of these atomic structure tables, just the way I approach them at least, is that there are kind of three main things to work through. And so that first thing to work through has to do with one of the first tables that you saw in that set of notes. And that's just kind of your identification of an element. And so we made a big deal in those notes that it's the atomic number that identifies an element. And so that's where you need to start, is what I call the identification. And so the identification involves four parts of this table. And so the first part is going to be the name of the element and the symbol, and both of those are in the periodic table. I mentioned the atomic number, and then also the number of protons. So all four of those things help identify the element, and they also are all found on the periodic table. And so you need to start here. You could actually start other places, but it's just easier to identify first. And so you'll notice that of those four things, I've only given you one, and that's the number of protons. But all you ever need of those four green columns is one piece of information, and I can give you anything. If you look down ahead to row 2 and row 3, you can see I'm giving you different pieces of information for those four green columns. Now in the current one, row 1, we're told 83 protons. That's the only information that we are given. And so the first thing to think about is that the atomic number and the number of protons are going to be the same number by definition. And that means immediately that you can just place the number 83 as the atomic number. Those will always be the same. And so as I go down this row, and I go down, I'm sorry, that column and that column, those should be the same numbers all the way down. Now you need to be real careful because I'm not always going to keep these tables exactly the same, meaning that right now atomic number and protons are right next to each other, but on a different worksheet, they may be in a different place. And the reason I'm doing that is you can't just memorize, oh, these two columns are always the same number. I need you to understand what those columns represent and how to find them. So you need to always look at the top and understand which column is being solved for. Great, so we have atomic number and protons being the exact same. We're able to do that right away. The next thing you want to do is look at your periodic table, and you're going to kind of trace those numbers that are increasing to the right, kind of read it like a book. And as you get down to number 83, you see a big, huge 83. On this one is a big blue. In other periodic tables, it might be different colors, but it's going to be bold and obvious, and it's going to be a whole number. And I'll mention this again at some other point, but you should never, ever be pulling those numbers with the decimal places. You are not ever pulling those into this table. And so please do not do that because that's a silly thing to be doing. You just gotta make a note right now somewhere. Do not ever pull those numbers. We won't use those until a later unit. And so what we're gonna do now is, now that I've identified where that is on the periodic table, I'm gonna look and there's a big VI, and that is the symbol. You need to be careful. You do need to use capitals and lowercase properly because it could mean different things if you're not. And then right below that, at least on my periodic table, this is bismuth. So now you'll notice we got the four pieces of identifying information complete. And again, all we needed was either atomic number or element name or symbol. And then you can easily get the other three pieces of information. And it'll always be that case. All right, the next thing to think about would be mass. And so the mass number obviously is going to be involved when we talk about mass. But then you also need to think back to the notes, and we talked about this, that all of the mass for an atom is coming from the nucleus. And within the nucleus are neutrons and protons. You'll notice I'm not including the electrons. While they do have a very, very tiny little mass, it is so small compared to protons and neutrons, we don't count them. So you'll see there are 3 blue columns, and those are all related. Now, the big thing here is that for mass number, we will get the mass number by adding protons and neutrons. You will always have the protons to start because you've gone through and done the identification from the green column. So we know there's 83 protons here. That means that either you're solving for the mass number or you're solving for neutrons. And I have to give you one of those. So remember, protons plus neutrons equal the mass number. You will always know protons. And in this case, I'm given I know protons, I'm given the neutrons, and we're just gonna add those together. So 83 plus 126 gives me a mass number, protons plus neutrons, of 209. And that's it for the mass. And then the final piece of info that we need to solve for is going to be electrons right here. Now, electrons are relating to the idea of an ion, and that was something we also went through in the notes. But an ion is an atom with a charge, and if an atom has a charge, that means there is a difference in the number of electrons versus the number of protons. So when we talk about electrons and protons and overall charge, we're looking at the proton-electron columns. You'll see there's also going to be a slight inclusion of the symbol. So let's work through this first one, although I'm going to have to reference the 2 below. There are 2 ways that I will tell you that you are dealing with an atom with a charge, which means the protons and electrons are different numbers. One way I can do that is shown in row 2. Notice that for the second example that we'll get to, I'm showing you a charge on bromine. And I'm trying to, when I do that, or you see that, time out, you've got an ion. And if you've got an ion, the proton and electron number cannot be the same and will not be the same. The other way I could try to make it very clear to you that I want you to know you're dealing with an ion is if I give you the number of electrons. If I give you the number of electrons, I'm saying there's something special about what's going on with protons versus electrons. Time out, you've got an ion. And so we'll get to those other 2 examples in just a moment. But what I want you to realize in our first example, I'm not given a specific number of electrons, and I'm not given any kind of symbol, in terms of a positive or negative charge on the element symbol, because we put that together. So I have no information telling me if there's different numbers of electrons or an ion involved. And if you are not given information like that, then you assume that the atom is neutral. And if there is no overall charge and the atom is neutral, that means that these protons and these electrons must be the same number. I know there's 83 protons. I figured that out very, very early on, and it was given to me in this one. That means I'll have 83 electrons. So 83 electrons, each negative, 83 protons, each positive. That cancels out as neutral, and you are done with that first example. Next, let's look at the second example here. All right, so again, let's look at those identifying characteristics. You should always be doing that. So the light green columns are where you want to start. And as I look at that, they have given me the element symbol. Now I know, we just talked about, I know there's that 1 negative or 1 minus charge on it. Let's just focus on the symbol itself. And it's going to take a little while at first, but you're going to scan the periodic table and you're going to look for Br as a symbol, and eventually you'll find it off to the right. And you'll see that Br is bromine. And very clearly, big whole number, 35. And remember that that 35 represents both atomic number and number of protons. So just like that, just by looking at the periodic table, I've gotten all of my identification information. So next, again, the way I would do it, you could do ion right now, you could do electrons, but I would just take care of mass. So again, we're going to look now at mass, and we're looking at the blue columns. Mass number is given, and I know protons. What I do not know are the number of neutrons. And what you need to remember is that neutrons plus protons equal mass number. So 35 plus a missing number has to equal 79. So that's just some easy math. So you will take 79 being the mass number, so protons plus neutrons, 79. So protons plus neutrons minus the protons gives me 44 neutrons. You always double check yourself. Do the protons and the neutrons add back up to my original mass number? And in this case, they do. So we're done with mass. The final thing is then electrons, and in kind of a broader sense, ions. Remember, ions are atoms with a charge. And I need to figure out, am I being told that this is an atom with a charge? And as we mentioned a little bit earlier, we are very clearly being shown that this bromine atom is an ion, and that it overall has a -1 charge. And so as we think through this, we want to somehow have a number of electrons that allow us to have an overall negative charge. So that means I'm going to need one more electron than proton. The thing about this is we've already identified this atom as bromine, has 35 protons. You cannot change protons because you would be changing the identity. So if you're like, I'm going to do 36, I'm going to do 34 instead. Well, that's selenium. Or if I'm going to do 36 protons, that's krypton. You cannot change a number of protons. What you can very easily change are the number of electrons. So we're going to use electrons to get charges on atoms, either by removing them or adding them. So in this case, if I want an overall negative charge, and I can kind of draw this down here. If I have 35 protons, and let's say I have 35 electrons. Well, if you think of a positive 35 and a negative 35, right, each electron's negative, so it's -35, and each proton's positive, that's positive. That cancels out. So that wouldn't work. And I can't change 35 protons. But what I could do, sorry, you can kind of see it down there. I could make that 36 electrons. 35 protons means it's still bromine. But if I add one more electron, I'm adding a negative charge. And we still only have the 35 protons to counter that. So that means I have one leftover electron, which means I have one leftover negative charge. So I want 36 electrons. By having one more electron, 36 compared to 35, I'm able to get a -1 charge, and this bromine then becomes the ion. And notice that the proton number and the electron number are different. Notice up above, the proton number 83 and the electron number 83 means it's neutral, and there is no symbol on the bismuth there. Okay, let's move on to this last one. So again, here, in terms of the light green, I'm being told sodium. The other light green columns that identify are blank. So I'm going to scan the periodic table. And again, you're going to get so used to the periodic table and some of these elements that are common, like sodium, you'll realize that it's number 11. So I look at sodium, and I'm going to carefully write down Na as the symbol. Sometimes the symbols do not match the name, and you got to be careful on that. And then also, again, within that box, I see a big, bold, whole number 11. That is the atomic number, which is also the number of protons. Great. The identifying stuff is over. And I always move on to mass next. So now I'm looking at those blue columns. And remember, you're either going to have to solve for mass number or neutrons, because you will have protons from the previous work that you just did. In this case, they gave me neutrons. And remember that mass number is protons plus neutrons. So they tell me 12 neutrons and 11 protons, and 11 plus 12 gives me a mass number of 23. So we are done with mass. Now, the final thing is to think about whether this is an ion where protons and electrons are different. So we're looking at that pink color for the columns. And what I'll notice is that the number of protons is 11. And I'll write this down below. And the number of electrons is specifically given to me. So anytime they tell you a specific number of electrons, we are telling you it's an ion. If we didn't want you to worry about an ion, we just leave it blank, you put 11 in. But because we specifically took the time to tell you 10 electrons, then you are worried about an ion. All right, fine. So we have 11 protons and we have the 10 electrons. And we can just be done. Not yet. If you look, there's some pink on the element symbol. And so we need to tell the person who's looking at this element that there's a charge. And so when you look at the math down here below, you'll realize that with 11 protons, that's like saying a plus 11 charge. And each electron's negative and you have 10 of them, so that's like a 10 minus charge. And overall, our charge is plus 1. The other way to think about that is if you compare the two, you have one more proton with a positive charge. But one way or another, you need to kind of figure out that this sodium is an ion and it's got a plus 1 charge. Now, technically, you should be writing this as a 1 plus is correct, although you can also just do a plus sign, and that's fine as well. We want you to get away from a plus 1 being put on a symbol. That's going to mean something very different as we move through chemistry. And so you can either do just the plus. I always put 1 plus because I don't want to get in the habit of only ever putting a plus and it's supposed to be a 2 plus, and then I forget. So, okay, I know it's a little bit long, but I'm hoping that that kind of detailed work through of one of these atomic structure worksheets might help just kind of solidify some of this. And again, practice makes perfect on this. And so I can give you more practice. And again, if you go through this and you think you're doing the right thing and you turn in that worksheet and it's not what you wanted or expected, let's meet during office hours this week and we'll review it real quick. We can talk about some of the ones you might have gotten incorrect, and then you can redo the worksheet. But if you're going to redo the worksheet, I need to see you either during office hours or some other time where we can at least just kind of chat on where were you going wrong. And maybe it was just a silly math mistake a couple times. And if that's it, I'm going to let you go right away and redo the worksheet. If we need to kind of go through and really relearn some of this, we'll do that together. All right, I am hoping that that is helpful. And again, communicate if you're having any issues, communicate if you're wanting to come in for office hours so that you can redo the worksheet. And hopefully this helped. All right, we will see you in class.